Okay, this video is for experiment number 8, modal analysis. Most of the equipment you're using is the same as it was for experiment number 7. We have here an anti-aliasing filter, an oscilloscope, and instead of there's no signal generator here, but instead what we're using is an accelerometer. This is an accelerometer that's been attached to a piece of well, in this case, aluminum metal hanging from the ceiling, which simulates a free beam. In this case, the accelerometer is connected to the middle of the beam all the way at the bottom extremity. That is connected to a what you could call a preamplifier, or basically it's an amplifier for the accelerometer. That goes to the anti-aliasing filter, which in turn gets outputted to both the oscilloscope and to Logger Pro, which thereby allows you to read to collect data from your computer. So the only other thing that you have is an impulse hammer. And basically what you have here is the accelerometer is used to measure vibration. So what you're going to be doing is, according to the instructions in the experiment handout, you're going to be tapping, or tapping the bottom part of the beam in order to excite the vibrations. Again, you want to tap it in such a way that it doesn't twist as much, because the accelerometer will pick that up as well as the vibration. So try your best to hit it and keep it from swaying back and forth. That's going to go to your amplifier, and then also go to the signal generator, or the anti-aliasing filter. What you want to do with the anti-aliasing filter is set the gains on the anti-aliasing filter so that when you tap it, it's overloaded, just barely. And what's going to happen is that the vibrations die out. You're going to see these overload signals start to blink. So as I demonstrate right now, you see that I'm tapping it. You see that they're on, and then now they're starting to blink as it dies out. What you want to do is then to start sampling your data at the approximate time that the overload lights start to blink. Note that your anti-aliasing filter cutoff frequency should be just at the above point, just at a value slightly above the fifth flexural frequency that you calculate from the equation in the lab handout. I think the lab handout gives you maybe 20 or 30 hertz, says to set this cutoff frequency to 20 or 50 hertz above it. And then you need to pick an appropriate sample rate and length of time to record on your on Logger Pro. And again, there's going to be 4 locations, 2 locations on the bottom, and then measure out to the middle of the beam. You should have there should be a tape measure available for you, and then you'll have 4 accelerometer positions. Basically in the bottom part, in the center, the side, and then in the central portion of the beam, again in the center and on the side. And then you're going to collect 5 data sets per accelerometer location. Okay, that concludes this video. If you have any questions, definitely let me know, and I will see you in class.